So this is a video for Algebra 2, Opt 1, day, I believe this is day 4. And we are looking at topic 1, exploring and analyzing patterns, which is module 1 of, it's in module 1, topic 1, lesson 1. Okay, module 1, topic 1, lesson 1, which is on page 3 of the volume 1 book. And we're looking at patterns and just observing patterns, which is an important skill for mathematics, is looking at patterns and trying to understand problems using patterns. Okay, so our learning goals are to identify multiple patterns within a sequence and use patterns to solve problems. Okay, so starting with the review, which is on page 3, you are going to look at this pattern. We're going to describe design number 4 and draw the design, and then describe the observable pattern and however you are thinking about it. Okay, there's more than one answer for how you can describe it. Okay, so I want you to pause the video and I want you to try these 2 problems, and then when you're ready you can unpause it and we'll go over it. So here's what I came up with for design 4. What I noticed was they are adding a new row to the bottom. So from design 1 to design 2, we are adding a row of 2 blocks. From design 2 to design 3, we are adding another row of 3 blocks. So from design 3 to design 4, we are adding a row of 4 blocks. So that's how I'm going to think of it. Okay, describe the pattern. So each design adds a new row of blocks, and you can also think of it as the number of blocks we're adding to it is equal to the design number. Okay, it's equal to the design number. It's always important to keep in mind the design number when you're looking at visual patterns like this, because it could come into play into like a formula. Okay, so now we're looking at the getting started. So let's go ahead and read that. So it says, covered in bees, you can find patterns everywhere. Sometimes you can describe them in terms of color, shape, size, or texture. Other times, a pattern's beauty is evident and isn't evident until you can describe it mathematically. Let's consider a pattern found in nature, the family tree of a male bee. Female bees have 2 parents, a male and a female, whereas male bees have 1 parent, a female. In this family tree, the parents appear below the original male bee. Okay, so we have a diagram. Okay, so blue is the male and this orangish color is a female. Okay, so just to reiterate again, we have females have 2 parents, males have 1 parent. Okay, now you're probably gonna read this upside down, so let's make sure we're reading it correctly. Think of it like you're reading it back in time. Okay, so this blue male bee, his only parent, that's his parent, is a female. Okay, so you're used to seeing like family trees, like there's me, and then there's mom and dad, and then there's grandparents. We're reading this upside down. Okay, it would be as if it was you, and then your parents, and then there. So it's kind of a little bit backwards. Okay, so we can see the female has two parents, a female and a male. The male only has the female parent, etc. Okay. So what are we going to do with this? We need to analyze this. So let's look at some questions. So the total number of bees in each generation follows a pattern. Describe the pattern for the number of bees in each generation. So let's look at the total number of bees, which is this number on the right. So it's 1, 1, 2, 3, 5, 8. Okay, let's look and make a list of those numbers. 1, 1, 2, 3, 5, 8. Dot, dot, dot. Okay, it is going to continue on, but we're just going to look at those numbers. All right, so maybe you see the pattern, maybe you don't, but we can at least list it for this first part. Determine the number of bees in the next 3 generations. So I don't know if you've recognized this, but this is a very famous mathematical pattern called Fibonacci sequence. Fibonacci sequence is basically saying you add the previous 2 numbers to get the next term. So if I add 1 plus 1, you get 2. If I add 1 plus 2, you get 3. If I add 2 and 3, you get 5. If you add 3 and 5, you get 8, etc. So if I continue this pattern, I'm going to have 5 plus 8, which is 13. That's the next generation. Okay, so that's 13. Then I'm going to do 8 plus 13, which is 21. And then I'm going to do 13 plus 21, which is going to give us 34. Okay, so our answers were 13, 21, and 34. So what is the mathematical rule that describes the pattern here? Basically, we're adding the previous 2, okay? So if we add the previous 2 terms or generations in this example, okay, we get the next generation. We get the number of bees in the next generation. So the pattern here was both a visual pattern where we can see the visual representation through a diagram, and it's also a numeric pattern because we could see the sum of these, the number of bees in this generation. Okay, let's continue on. So activity 1, we're going to look at some more patterns. So there may be multiple patterns within a sequence. You can use these patterns to solve problems. Okay. So here's our next setup. Miriam owns a flooring company. Her latest job involves tiling a square room. Miriam's customer, Mr. Rivera, requests a tile pattern of alternating blue, white, and green tiles. Each tile is 1 square foot. Okay. Blue, white, green, blue, white, green. Okay. But it looks like it's going outward, like in rings. Okay. So the first design is just 1 blue tile. Design 2, we have a ring of white around that blue tile. And then we do a ring of green around that tile. Okay, so you see we're going beyond that. Okay. So analyze Miriam's design for a tile pattern for a square floor. Describe as many patterns as you can. So I want you to think about like the number of tiles in each design, the number of new tiles in each design from the previous one. Is there a pattern that has to do with the design number? Maybe you need to draw another design to see what the pattern is, okay? So I want you to pause the video and I want you to see how many patterns you can come up with. So the obvious pattern is the one that it was designed around, which was the colors are alternating blue, white, green. But then let's look at the number of tiles along each edge. So edge is just like one side. So there's 1, 3, 5. That's a pattern. And what we can note about that pattern is it's odd numbers. So that tells me that design 4 is probably going to have 7 along the edge. Okay. Now let's look at the number of new tiles being added to each design. So before we had 1, and then we added this ring of white, which was 1, 2, 3, 4, 5, 6, 7. So we added 7 tiles there. And then from there, 1, 2, 3, 4, actually, sorry, it was 8. I miscounted. 1, 2, 3, 4, 5, 6, 7, 8. And then from design 2 to design 3, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'm thinking that we're adding multiples of 8 here. So first we added 8, then we added 16. So does that mean we're going to be adding 24? Or let's find out. Maybe we need to do another one to see what's happening here. And then the number of total tiles. So these are squares. The first one, there's 1 tile, so that's 1 square. If this is a 3 by 3 square for design 2, then I'm just going to do 3 squared, which is 9. Okay, and then this is a 5 by 5 square, so then it's going to be 25. So those are perfect squares. All right. Sketch a design for the square floor that is 9 by 9 feet. Okay, so let's think about, first of all, they give us this grid here. We got to think about the colors. We also have to think about the number of like rings, I guess. So 9 by 9, we can go outward towards the end. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to take up this entire grid here. So we don't know what the color is quite yet. I'm just going to make a set of rings basically here, and then I'll worry about the color. Okay, just keep going until we get to the middle. All right, and so remember our coloring is blue, white, green, blue, white, green. Okay, so I'm going to use a blue highlighter here. You can use a B for blue. White, I'm going to leave blank, and then green, and then blue, and then white. So I leave that one blank. Okay. Let's take a look at what we see here. We have an edge of 9 by 9. Okay, we have a total number of 81. Okay, but let's go ahead and take a look at the next part of this. It says a hotel manager wants Miriam to tile their lobby using the same design she created for Mr. Riviera. That lobby measures 45 feet by 45 feet. So remember that each of these tiles is 1 square foot. So this one would be 9 feet by 9 feet. Okay. So the hotel manager wants the outer edge the same color as the center tile. Will this occur? Okay, so you could draw a grid with that's 45 by 45, and you can do it the thing we just did, and then you can see. But that's going to be really tedious. I don't want to do it. You don't want to do it. So what we should do is let's think about this in a way that we don't need to draw it. Okay, we need to think about how many rings there's going to be. Then we could use the pattern blue, white, green to see if it's going to end up with the outer ring being the same as the inner ring. So, or the inner tile, right? The outer edge Well, the inner edge is blue. The center tile is blue. So our goal is the outer edge to also be blue. So really the question is the outer one going to be blue? Okay. So how can we work backwards to get this answer efficiently? We want to think about how we're going to get that color. Okay, so I want you to pause and think about it. See if you can come up with a system for figuring it out without drawing the grid. Okay, so go ahead and pause. I want you to think about it. Okay, so one way that you can determine it is to figure out what the design number is so that you know how many rings are going to be there. Basically, the number of rings, as I'm calling them, is going to be the design number. And maybe we can figure out a pattern between the design number and the edge. So, because we know that's 45, right? The design here is 1, and the ring, there's one block along the edge, or one tile. Design 2 has 3. So they're not the same number. There's something going on. Design 3 has 5. Okay. Let's look at design 9. Or actually, did we figure out what this design was? We can figure out the design. This is design number, and you can tell the design number by the number of rings. 1, 2, 3, 4, 5. This is design number 5, and that led to 9 by 9 feet. So how are we going to work backwards to figure that out? So we know it's 45 by 45. One way you can kind of think about it is that's one ring. There's 2 blocks that make up that ring, and then 2 blocks that make up that ring, and 2 blocks that make up that ring, and 2 blocks, and then there's 1 in the middle. So it's like there's the number 2 here. So 9 you can think of as 2 times 4, because there's 4 rings, plus the block in the middle. Okay, so by 4 rings, I mean around the blue one in the middle, right? There was 1, 2, 3, 4. So maybe there's something going on with 2 times 4 plus 1. Okay, well, where did the 4 come from? Remember, this was design 5, so maybe this number is 1 less than that. Let's test it out on one of the other ones, okay? So here was design 3. What if we do, so my thought, let's just clear it up. I'm thinking this is 2 times the design number minus 1 plus 1 at the end. That's my pattern here. That gives you the edge, the number of blocks on the edge. Okay, so let's try it on this one. There's 5 blocks on the edge. It should be 2 times the design number, which is 3, minus 1 plus 1. So that's 2 times 2 plus 1. It worked. Okay? So if that's our pattern, we know our edge to be 45. We're going to do 2 times the design number minus 1 is equal or plus 1 extra block. Okay. I don't know what the design number is. That's what I need to find out. Let's call it X. Hey, it's an equation. Let's solve for X. Let's distribute the 2. And combine our like terms. And we'll add 1 to both sides. Get 4x is equal to 2x. And divide it by 2. There it is. The design number, that's our x, is 23. Okay, so there's 23 rings around this. So now what I'm going to do is I'm going to make the pattern with the 23 rings, but I'm not going to draw it. I'm just going to write like a color code here. All right, so I'm going to do 23 rings, and I'm going to imagine what it's going to end up with. So we got blue. That's the first one. White, green, then blue, white, green. There's 6. Blue, white, green, blue, white, green, blue, white, green. Okay, this is taking a while. How many am I up to? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, maybe I can think about this a little bit more and not have to write these all out. Maybe I just need to do a little division. So every 3, it starts over, right? So maybe how many groups of 3 are in 23? Because then it'll just start over, right? Well, 3 goes into 23 7 times. It's 21 with a remainder of 2. So what that remainder is telling me is going to go blue, white, green, blue, white, green, blue, white, green, dot, 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 dot. And then it's just going to start a pattern again, but it's only going to go blue, white. It's not going to get the green because there's only 2 of them. Okay. So blue and white means the very last one is white. We figured it out. Okay, so finally, to answer the question, the hotel manager wants blue on the inside and blue on the outside with 45 by 45. He's out of luck. Will this occur? No. So let me write my answer. No, this will not occur. It will be white, not blue. So you could see how we used algebra to really solve this question, okay? All right, now let's take a look at this one. One of Miriam's clients wants the alternating blue, white, green tile pattern. However, she wants the outer edge of the tile to match her wall color. The room is 101 by 101, and the wall color is white. What color... Ooh, they're changing the question here. What color must the center tile be to ensure that the outer edge is white? Okay, so we're going to do blue, white, green, but we can start with any of those 3 colors. Okay, so let's pause and think about that. Draw a diagram. Write out some letter codes, do some division, kind of like we were just doing, and go from there. So let's take a look at this question. What color must the center tile be in order to ensure that the outer edge is white? So I did a little work to figure out that there were going to be 51 rings of tiles going outward. So if you remember from the last problem, if we divide the number of rings by 3, we can see how many complete rotations of the pattern you're going to have. So let's do a little division. 3 into 51. Actually goes perfectly evenly. So there's no remainder. And that's important because it tells us that it's going to end on whatever the cycle is. Okay, so we want it to end on white because we want the outer edge to be white, right? So the center tile is going to follow this pattern, blue, white, green, blue to white to green. But we kind of want it to end on white. So this would be the end of the pattern. So we could really start it at green, then go to blue, then go to white. So I'm starting at this, which would then loop back to blue. So green to blue to white. Green, blue, white, green, blue, white. So it's going to go green, blue, white 30, oops, that's a mistake right there, 17 times. So it's going to do green, blue, white 17 times because 3 times 17 is actually 51. And then from that would mean that it's going to end on white, which is what we want. So the color at the center would have to be green. Okay, so that's our answer. In the center needs to be green. All right, let's take a look at activity 2. Recognizing or reasoning with patterns. Okay, so we've been using visual models to reason with patterns to solve problems. So let's continue to do that. So we have an election. The election results for the homecoming king are generally kept a secret until the principal announces the winner in a pep rally. The class president, vice president, and treasurer of a high school count the ballots for the homecoming king election. The very next day after counting the ballots, each ballot counter tells 2 of their friends in the senior class the election result. The following day, each friend of each ballot counter shares the election. So it's a rumor, basically. It's a spreading of information. It's gossip. So let's start by creating a visual model. So there are the class president, the vice president, and the treasurer. There's 3 people who are ballot counters, okay? Let's see, where am I going to put this? So 1, 2, 3 people. Those are my people. And each day they tell 2 people. Okay, and each day it says that they each share with 2 of their friends. Whoa, this is going really quickly. So there's my very simple visual model. Okay. It also says we can assume that no student is told the result of the election twice. How many new seniors will know the winner of the homecoming king election on the 4th day? So we got to go all the way to the 4th day here. So this was day 1, day 2, day 3. So maybe we don't have to draw it that far because it is going to be a little tedious at that point. But I'm going to count how many people are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to double that because I'm just going to go like that. But I don't want to draw that. That's annoying. So we're going to do, I'm going to say 24. And how did we get that? We, so double the number of people from the previous day. So now that we know sort of the pattern is that we're doubling each day, we could also figure out like the total number of people that now know, right? We can make a table. Table is a great way of organizing information that we don't know. So we can have days, so we have like day 1, day 2, day 3, day 4, etc. I'm gonna go long-wise because it fits better. And then we also need to know like, okay, how many new people know? So we'll say new seniors that know, that found out. And then we can do total. So on the first day, 3 people knew. So let's just do the ones that were new seniors, right? Then it doubled because those 3 people told 2 people, so that's 6. Doubled again, 12. Doubled again, 24. So that was the answer to the previous question. And then 48, 96, etc. Let's see, 96 times 2 is 192. Okay, but then the total number of seniors, you got to add this up. So first those 3, and then you add the 6 to the original 3. That gives us 9. Now we add the 12 new ones to the 9 from the day before. That gives us 21. Now I take the 21 and I add the 24, so 45. Okay, let's see, 45, we're going to add 48 people. 93. Okay, and then 93 plus 96, 189. And then 189 plus 192 is 381. Okay, so let's answer this question. Okay, so the ballot counters know the election result on Monday, and the total number of students in the senior class is 250. Will every senior know that the election of the result when the principal announces it on the prep rally on the 6 days later? Okay, so be careful to notice that it says 6 days later, not on the 6th day. Okay, so on the 6 days later from the original day, we are looking at day 7. And the total number of seniors at that point that know are 381. There's only 250 seniors in the whole school. So are they going to know? Yeah, they're going to know. Everybody's going to know. It's not going to be a surprise anymore. Okay, so I'm not going to do activity 3 with you, but pretty much you're just looking at another pattern. Okay, and trying to identify like the largest pattern you can make on, you're supposed to maximize it, but it's just looking at another pattern, okay? If you need help with this one, you can definitely look at the answer key if you get stuck on this one, but try to do it on your own first and then check with the answer key. All right, that's it for this video.